Hi friends, today we see about universal joint. So universal joint used to connect to parallel intersecting shaft. This can also be used for shaft with angular misalignments where flexible coupling does not serve the purpose. Hence, Hooke's joint is a means of connecting two rotating shafts whose axes lie in the same plane under their directions, making a small angle with each other. Next, rack and pinion. The rack and pinion is used to convert between rotary and linear motion. The rack is a flat toothed part, the pinion is a gear. Rack and pinion can convert from rotary to linear, of linear to rotary. The diameter of gear determines the speed that rack moves as the pinion turns. The rack and pinions are commonly used in the steering system of a car to convert the rotary motion of the steering wheel to side motion in the wheels. Rack and pinion gears give a positive motion, especially compared to friction drive after wheel in tarmac. In the rack and pinion, railway a central track between the two rails engages with the pinion on the engine, allowing the train to be pulled very steep slopes. This is the diagram for rack and pinion. The green color which indicates the gear, then yellow color specify the pinion. If you rotate the gear, the pinion move to and fro. It generates a linear motion. Then double slider crank chain. A kinematic chain which consists of two turning pairs and two sliding pairs is known as double slider crank chain. They are elliptical trammels, Scotch-Yoke mechanism, Voldom coupling. The inversions of double slider crank chain, elliptical trammels. It is an instrument used for drawing ellipses. The inversion is obtained by fixing the slotted plate. The fixed plate or link has two straight grooves cut in it at right angles to each other. The link 1 and link 3 are known as sliders and form sliding pods with link 4. The link AB is a bar which forms turning pair with link 1 and 3. When the links 1 and 3 sliding along their respective grooves at any point, the link 2, such as speed traces out an ellipse on the surface of link 4. A little consideration will show that AP and BB are the semi-major axis and semi-minor axis of the ellipse respectively. This is the elliptical trammel. Let us take OX and OY as the horizontal and vertical axis. Let the link BA is inclined at an angle theta with the horizontal. Now the coordinates of the point B on the link BA will be x is equal to PQ, that is equal to AP cos theta, and y is equal to PR is equal to BP sin theta, or we can write as x by AB is equal to cos theta and y by BB is equal to sin theta. Squaring and adding x square by AP square plus y square by BP square is equal to cos square theta plus sin square theta is equal to 1. This equation of an ellipse, hence the path traced by point P, is an ellipse whose semi-major axis is AP and semi-minor axis BP. Then next is Scotch-Yoke mechanism. The next one is Voldom coupling. And Voldom couplings is used for connecting two parallel shafts whose axes are at same distance apart. The shafts are coupled in such a way that if one shaft rotates, the other also rotates at the same speed. This inversion is obtained by fixing the link to. The shaft to be connected have two flanges rigidly fastened at their ends by forging. The link 1 and 3 form turning pairs with link 2. These flanges have diametrical shots for their inner faces. The intermediate piece, which is a circular disc, have two tongues, diametrical projections T1 and T2 on each face at right angle to each other as shown. The tongues on the link 4 closely fit into the slots in the two flanges, link 1 and 3. The link 4 can slide or reciprocate in the slats in the flanges. The inversions of mechanism. The method of obtaining different mechanisms by fixing different links in a kinematic chain is known as inversions of mechanism. It's a 4-bar chain, basic kinematic chain of a 4-bar chain, frame AB, crank AD, coupler DC, output link BC. The inversions of 4-bar chain: crank and lever mechanism, beam engine, double crank mechanism, coupling rod of locomotives, rocker or double lever mechanism, that is Watt's indicated mechanism. Beam engine. In this mechanism, when the crank rotates about the fixed center A, lever oscillates about a fixed center D. The end E of the lever CDE is connected to a piston rod which reciprocates due to the rotation of the crank. In other words, the purpose of this mechanism is to convert rotary into reciprocating motion. Then coupling of rod of locomotives. In this mechanism, the links AD and BC acts as cranks and are connected to respective wheels. The link CD acts as a coupling rod and the link AB is fixed